Hey there, Mr. Sutton here, bringing you the IM3 Honors 1-2 Extra Practice number 4 solutions on operations and compositions of functions. For this problem, I'm doing g of f of x. So I'm basically taking this f of x expression, which is really just 4x, and plugging that into g. So I'm doing g of 4x. So g does 2 times something minus 4. So we're going to be doing 2 times negative 4. Minus 4. So this x in the g function just getting replaced with this 4x that was f of x. And then simplifying, this is just 8x minus 4, and we can't do better than that. For this one, I want to do f of g of x. So I'm taking my f function, which does 2 times something minus 1, and I'm plugging this g into it, which is x cubed plus 4x. So I'm going to be doing 2 times, big parentheses, all this stuff right here, x cubed plus 4x, all of that, and then a minus 1. Just erasing and replacing this x with x cubed plus 4x here. Once I've done that, I can simplify a little bit by distributing the 2. So that's 2x cubed plus 8x, all of that minus 1. And there's no like terms to combine, so we are finished. On this one, I want to do h of g of x. So the h function, you'll notice, takes whatever you plug into it and does something squared plus 3 times the same something. What's the something in this case? Well, I'm plugging g into h. G is just a 4x minus 1 expression. So instead of doing x squared plus 3x, I'm going to be doing parentheses 4x minus 1 squared plus 3 times 4x minus 1. All right, and now we have to simplify. So let's see here. This first one, I'm going to be doing my a squared plus 2ab plus b squared kind of shortcut here. So squaring this first term gives me 16 squared, and then multiplying these two terms and doubling it. Negative 4x times 2 is negative 8x for the middle term, and then squaring the last term gives me positive 1. Distributing the 3 over here, we've got 12x, and then 3 times negative 1 is minus 3. And as a last step, I can combine some like terms. 16x squared, nothing to combine that with, but negative 8x and 12x gives me a 4x plus 4x, and 1 minus 3 is negative 2. For this problem, I'm doing g of f of negative 3. So I really need to do f of negative 3 first and figure out what that is, and then I can plug that number into the g function. So let's start with f of negative 3, which, using my f function here, is going to be negative 3 squared plus 2. Notice I put the parentheses around the negative 3. So this really means negative 3 times negative 3, which is 9, plus 2, giving me 11 there. And now I had to do g of whatever f of negative 3 is. So I'm doing g of 11. This is just going to be then, using my g function, 11 minus 4. So this 11 got plugged in for the a here. And 11 minus 4 gives me 7. On this problem, we're doing f of g of 0. So the long-range thing that's happening here is I have to plug 0 into the g function, get a number, and then plug that number into the f function. So we need to find g of 0 first and work our way out. G of 0, that's 0 plugged in for the t in the g function. So 2 times 0 plus 4 will give us g of 0. 2 times 0 is 0, plus 4 gives us 4. So that's what g of 0 really is just 4. So for the problem now, I have to do f of 4. That's going to be 4 squared plus 4, using this f function here. So that's going to be 16 plus 4, which is 20. On this one, we're doing g of h of 3. So I need to figure out h of 3 first, and then plug that number, whatever it is, into the g function. H of 3 is going to be 3 cubed minus 2 times 3, just replacing these x's with 3's in the h function. And let's see, 3 cubed is 27. We're doing minus 6, basically, so 27 minus 6 for 21. And now 21 is what I'm plugging in to the g function, because I'm doing g of h of 3, and h of 3 was 21. So g of 21 is going to be negative 2 times 21 plus 3. Negative 2 times 21 is negative 42. Add 3 to that, you've got now negative 39. And that's as far as we go on this one.